Welcome to another episode of the Concrete Logic Podcast. And today I have Alex Hall, CEO of Concrete AI. Alex was he actually did episode 33 back in December 2022. So it's been a long time since we talked to him, and I'm sure a lot has changed with AI and what he's doing with that in the concrete industry. So I'm excited to talk to him today. And but before we get started, just want to remind you all how this podcast works. So we do not we don't have any advertisement, we don't have sponsorships or anything like that. We do that on purpose so we can bring anybody we want on and not interrupt these great conversations that we have with our guests with your favorite deodorant or whatever. These people have their so that some of these podcast advertisements crack me up. Mm-hmm. But anyways, so there's three things you can do to support the podcast. The first thing is if you enjoy the podcast and you enjoy this episode with Alex today, please share it with a colleague in the industry so they you share the knowledge. The second thing you can do is if you go to concretelogicpodcast.com, on the homepage, there's a couple ways you can reach out to me. There's a contact button you can click on. You hit the contact button, you can shoot me a message. There's also in the bottom right-hand corner of the webpage, there's a little microphone. You can actually click on that and it'll leave me a message. It's just like leaving me a voicemail. Like if you were to call me on my cell phone, it would leave me a message. And what I'm looking for is ideas for guests or topics. So please do that because this podcast is for you all. So I want to have the topics and the guests that you all want to hear from. And then the third way is same thing on the Concrete Logic podcast on the homepage. On the upper right-hand corner, there's a donate button. And what we ask is if you get any kind of value out of the podcast today, you learn something from Alex, you hit that donate button and you can give any amount. There's no set amount. So we appreciate any amount that you give. And when you do that, we list you as a producer of the show. So with that, Alex, I was within the 3 minutes. I told you I'm doing good. Alex, thank you for joining us today. Like I said, he is the CEO of Concrete AI. Alex, can you give us I think people know what AI is at this point, but it's everywhere. Everybody's following NVIDIA's rise to I don't know where they're going. They're going to the moon and beyond. But anyways, Alex, can you tell us a little bit about yourself, a little bit about your background, because you do have a background in concrete materials, and then a little bit about your company, and then we'll roll right into the questions I got for you.
Awesome. Thanks, Seth. Appreciate having me on again. I enjoyed our last conversation. This one will be as good. So maybe let me get me out the way. So I was with Holcim for almost 20 years. Started with them in South Africa and had various roles with them and moved with them in the US in 2007. I was heading up their ready-mix concrete performance group. But I'd been involved in the business side, VP of concrete in the Midwest, so basically, and concrete and aggregate. So, I had a lot of fun, a lot of exposure there, and that actually ultimately led to me meeting my two other co-founders here at Concrete AI through the University of California in Los Angeles. We were always interested in disruptive technology, and one of the things I came across probably in 2016 was this guy holding up a filter. And it looked like a 3D printed filter made of concrete, and it actually was. And it became what is the precursor to a product called Carbon Built. So Carbon Built's a commercially available block that's out there right now, concrete block, but the way it's designed and the way it's structured is it actually absorbs CO2 when you manufacture it. So I think you'd be a really good guest to have on your show one day. There's a guy called Revolutionizing, who's the CEO of Carbon Built. But super interesting company. They ended up winning the 2021 X Prize for Carbon. And it's really a fantastic story that's born and bred in the US. Along some of the lines, we kind of kept on talking to the guys at the university, and decided how we're going to try and utilize AI to kind of reimagine concrete design more than anything. So once you have enough data around the physical and chemical properties of the raw materials of concrete, you can kind of predict how things are going to perform. And once you're accurate enough in your prediction, then you can start figuring out how you can model using the same materials, but to get either lowest cost or lowest embodied carbon. And really, that's exactly what this business is all about. We typically will connect to a producer's quality management system, get data from there as to their actual raw materials. So think of all the, whether it's the aggregate, the sand, the cement substitutes, the admixtures. All of these products are supplied, and they supplied in accordance with an ASTM specification. So if you think about the aggregate, right, the aggregate always has to have a cert that basically says this is the ASTM C33 certification. And within that, there's a whole lot of really important data, not only around the grading, but physical properties, things like moisture absorption, fineness modulus, the density, all these different kinds of things. But not just aggregate. Think of C494, C150 for cement, all these different things. And because it's supplied in accordance with an ASTM requirement, we can harvest this data and have a lot of trust in the quality of the data that's being provided. And so we take that information, we take the actual recipes that the clients have, and then we take a whole lot of test results, feed that into a set of neural networks or models that we built specifically for this, and then are actually able to predict how things are going to perform. Now, the reality is, bad data is no good. So there's a lot of scrubbing that has to happen on the front end and make sure that the data is really accurate and relevant. But the bigger the amount of data we have, the more accurate we can be in terms of the predictions. And so the business actually bifurcates into two different kinds of artificial intelligence. So one is the first that I mentioned, which is the predictive artificial intelligence that tells us, these are the materials that have gone into a truck, and based on that, this is how we think it's going to perform. So we'll give you things like set time, slump, compressor strength at 1, 3, 7, whatever interval you want, right? And that's all well and good because it's going to tell you how things are going to effectively work. But then if you kind of reverse engineer it and you say, a ready-mix producer's got anywhere between, say, 15 to 26 different raw materials available at their operation, including all the chemical admixtures. And now you go to the AI and you say, all right, let's take a different approach and let's use a different type of artificial intelligence. It's still within the same family of machine learning. But we're not just going to predict. Now what we want you to do is kind of do what a GPT does. And let's reimagine this. Let's give us a new mix design, given the same constraints that we had for the previous design and the same engineering criteria that we're looking for, and tell us what the optimal mix design for that looks like. And that's a different branch of AI, which then allows us to actually totally reformulate the mixes. We've got to be really careful about this because AI is phenomenal at crunching numbers, right? And taking huge amounts of data and computing that. It's a really great combination of big data and this artificial intelligence that you have all in one place. And concrete being as prevalent as it is across the planet, second most consumed planet in the world, there's a whole lot of data around it. And so you can get an output. But what's really important is that you also need a human being to provide some judgment to this. Because AI doesn't have judgment. It'll give you an output of a calculation based on an algorithm that it has, but it's not going to be able to make a judgment call. And that's where a human being comes in. And, as well as I do, I mean, think about how some guys, when they place concrete, they're looking for a certain kind of finishability. And the AI is not necessarily going to know, that's kind of where I want this thing to be within the Shilstone curve, for example, right? Mm-hmm. That's where the human being comes in. So, ultimately where we've gone is we've built this product, we call it Concrete Copilot. And the Copilot is there really as a co-pilot to the human. The human's still ultimately the person in charge and going to be driving it, but the co-pilot really just helps him with some of these, mass computation and number crunching, frankly, that folks don't have the time to do.
Yeah. And this, we talked about this in the last episode you were in, that, this is not a hands-off thing, that it's not going to spit out you the answer. And because that was one of my questions, I think I asked you was, hey, are we going to get rid of engineers now? And you said absolutely not. So yeah, that touches on that. So is all the information that you're feeding Concrete AI, is that information coming from just the ready mix suppliers, or how deep into the materials are you going?
Yeah, so we'll go all the way up to supply chain. So anything we can get, like even mill certs, that kind of stuff from the cement producers, like I said, the C33 documentation from the aggregate guys, any information that's got relevant information with respect to the constituents and the properties of those constituents, we're going to use and populate within the models.
Okay, because we just talked about this, I think, a couple episodes ago, and we've talked about before, is alkalinity and what it does to concrete. And the mystery, I guess, is the best way to put it. The mystery is what those aggregates have attached to them. Where's the cement coming from? What things that they're using to help them make the cement. I'm trying to make this as layman as I can. All those materials.
Right.
All those materials go into this, and then this is sent over to the ready mix supplier, and the ready mix supplier is banking on what these mill certs tell them. They mix this all together at the plant, and then it's on them to deliver this product to the job site and say, hey, this is how the concrete's going to act. This is what its strength's going to be. This is how long it's going to take to cure all these things. But really, they're dependent on what the aggregate suppliers telling them. They're dependent on what the cement suppliers telling on them. I imagine, since AI can crunch all this data better than a human can, I think we could do a better job at doing that. Is that part of what y'all are doing?
So yeah, no. So I think what you're bringing up is super important, because it's one of the reasons why there's very few companies doing what we do. If you have a look at the AI space, right, in its entirety, and you look at what they call kind of artificial intelligence for material optimization, you'll find a lot of different companies. There's Cabotics, there's Noble AI, Citrine. There's like literally a list as long as my arm of these different companies that are able to do things with materials and enhance them. The reality, though, is, think about this. Like, concrete's the second most consumed product on the planet, okay? But think about the number of ingredients that go into concrete. And I'm not talking about, just ingredient categories. Think across the planet. Think of how many different types of rock there are. Think about how many different types of chemical admixture and admixture suppliers there are. Every cement is slightly different chemically. We know this. Every SCM is also slightly different. So you've got, like, literally potentially millions of different input, and obviously the reality of all of these things is every one of them is a commodity. I'm sorry to the cement folks. I never like hearing that cement's a commodity, but ultimately the distance you are from the cement plant is going to determine the cost of distribution. And that's going to have an impact on, the cost of the powder in your silo. That's just the reality, right? So what do we know about commodities? Well, typically they don't travel very well, right? So, the furthest you'll see cement go from a plant is where you got a plant on a waterway, and it can maybe travel 500 or 600 miles down to a port somewhere. And that's as cheap as you're going to get it, because you're moving, up like tens of thousands of tons of product on barges, and that's how it goes. But aggregate, maybe 100 miles if it's already good. Well, actually, let me take that back. That's also not true, because here in Los Angeles, we get aggregate from British Columbia, for example. But again, coming on water, so the cheapest way of distribution. But if you're just moving rock on the road, maybe 100 miles, I'm guessing. And then same thing. Think about how far ready-mix goes. So this is a challenge, right? All the products are essentially pretty local, pretty centralized, and they're so diverse. You've got a range of different products that goes in. So modeling concrete is more than complicated. It's complex. It's a challenge to get this right. And just to add a little bit more complexity, think about the fact that you're using a series of admixtures with your concrete product, but how compatible is that with the grinding aids that the guys have used upstream in the cement? No one ever wants to jump into that, but that's something that I've seen that happen in my life. So it's a reality you got to be able to deal with. It's kind of one of the good things about when you model this stuff is that what you always want to try and do is you want to take into account the potential variability of these things. And so, for instance, with us, you'll always see the output of a prediction has an error range. So we'll say, okay, this thing's let's say you got like a 5,500 PSI target, right? And we're predicting that the reference mix is going to get to 5,600, but it's got an error range of 300 PSI up or down. So it could be as low as 5,300, but it could be as high as 5,900. Let's just say. Well, when we model for mixes that we're going to verify or back up, we will always take that error range into account. And so we become really conservative to start with. So we'll actually slightly over-design, but even with that over-design and take into account that error range that accounts for the variability of these different things, you can actually still have an optimized mix and still have your performance guarantees as well. So it really depends on how you want to model, but we've been pretty successful in doing that. One of the benefits is that over time, like I said earlier, the more data you get, the smarter things you become, because what we employ is a process known as active learning. So as we generate more mixes and more of the stuff gets tested and we get more test result data as feedback, so we continue to train these models, and these models actually get smarter over time, so that the degree of variability starts changing. But this is a reality. The one thing you're never going to change is 80% of the materials in concrete are naturally occurring. Between the sand and aggregate, it's not a manufacturing process. Right? This is commission. You're just changing the shape and you're sorting it into different gradations. That's what you're doing. And rock is naturally occurring. The last time I looked, no one manufactures rock. Well, I better take that back. There's some that are about to come online soon. But anyway. Mm-hmm. But it's naturally occurring, and like you can be in a quarry and like literally move 20 yards in one direction. There's a fissure, and you're going to have a slightly different chemical reality which you're dealing with, and as a consequence, have slightly different physical properties. And so, those are the kind of things you always try to model and incorporate into the data.
Yeah, it's ever changing. I mean, we've talked about before. Just talking about aggregates is, if you look back 3 or 4 decades ago, we were using round river rock, and now you don't see that anymore in concrete. So it's like you said, when you're out there digging for rock, it changes as you go down, changes as you move over. And
for sure. I mean, like, so, like a big ore body, like a quarry is probably the best, like from a consistency perspective. But, if you get into the Midwest, I mean, basically, think of Detroit through, all the way through, like, even St. Paul, those kind of places. The Minneapolis, the reality is that at least 50% of your material coming from sand and gravel deposits. Right. There's some limestone deposits, but that's basically entirely a sedimentary basin. There's not that many hard rock quarries there. And sand and gravel by its nature is significantly variable. I mean, you got some benefit in that some of the particles are already somewhat rounded. So from a packing perspective, there's some potential benefit in there. But, again, this doesn't always play nicely into the aggregate producer's hands either, because I can tell you, like, 2008, 2009 in Chicago, we had an operation out there, and we had, I don't know, more than 1.5 million tons of sand and stockpile just in one operation. And you can only cap that to a year's sale, so you've probably got 1.2 million tons of sand that in theory isn't on inventory, and you got to spread that cost over the rest of your products, and that becomes a challenge. I mean, that becomes a real big deal.
Can you share like what inputs you're using that you're putting into your model? I mean, I assume like compressive strength. Are you doing like flexural strength, temperature? What can you share a little bit?
All those different things. You can that's kind of the beauty with artificial intelligence, is that you're not limited to the number of dimensions you can model. So I would say kind of the vanilla stuff is exactly what you'd expect. F prime C, give me 28. That's what everyone needs. That's kind of typical. Give me a set time. Give me a slump. So I mean, I think that's happening. Everyone wants that, but you can go even further. And the reality is, as long as you have enough data to start training the models on, you can start going down any rabbit hole you want. So whether it's temperature, whether it's flexural strength, if you want to go as low as 20 hours, we've been able to do that as well in terms of predicting the actual strength at 20 hours or a day even, or sort of early stripping. I mean, you can do that.
Yeah. Yeah, we're something interesting that we talked about a couple episodes ago was actually going beyond the 28 day.
Oh yeah,
going, some of these, our favorite type 1L cement. They're allowing us now to do 56 day breaks, but we were looking at we had an interesting chart where the chart was showing based on the temperature of the concrete that when it was curing, that you might meet the 28-day strength, but the strength of the concrete actually becomes less over time. It had breaks at 365 days, and it actually showed that the concrete got weaker because of the temperatures were not optimum for curing conditions. So the podcast was all about focusing on the importance of curing. But the chart that the gentleman shared with us, Robert Higgins, he was showing that if you're not at the that right temperature, that you can actually have concrete that breaks at a lesser compressive strength further down the line.
Yeah, well, look, full disclosure, we don't go past 91 days at the moment. That's where we've taken the model to in terms of the limit. I mean, I think it brings up an interesting point of the conversation, because the one thing we are definitely starting to see is some more demand. It's not massive, but it's definitely increasing, especially with companies looking to build data centers and stuff. There's a real big focus on, lowest embodied carbon concrete. And, what does that normally mean? Well, normally means you're going to put as much SCM as you can into the product. Just take it as far as you can, and then, let me understand what my compressive strength is going to be at 56 and 91 days. And we've done that. It's, I think, it's going to be interesting, because as that market grows, I think we're going to see a little bit more, a different kind of pressure that folks aren't used to. And they're going to have to figure out how they can actually start supplying these products, because, slag and ash are definitely increasing at prices that seem significantly high from just direct inflation in comparison to cement. They're getting more pricey. And I mean, there's some regions here where slag's more expensive than cement.
Yeah.
So why would you use it? And this is just the reality. This is what we're going to have to face. So producers are going to have to think a little bit differently, but probably more importantly is, clients are going to have to figure out that there's a green premium that's coming, and they're going to have to, that's just a reality people are going to have to deal with. And it's not easy. People don't want to pay more for what they conceive to be the same product.
Mm-hmm.
It's not.
Yeah, they're going to have to prioritize. I mean, but just in 2020, fly ash mixes were a discount, and now, like you said, they're a premium now.
Yeah.
So,
but it's interesting, because there's a flip side to this as well, and it really all depends on the client, right? I mean, I was talking about data centers, for example, but if you have a look at any of the tech companies, what not quite sure where Amazon is on this train at the moment, but they've got a really excellent report in terms of where they're going on the decarbonization journey. But certainly, Apple, Meta, Google all have net zero targets at 2030. And that includes their scope 3 emissions. So scope 3 effectively is anything not directly associated with the business, but it still relates to things like their assets. So if you own a data center, you've probably got a big plot of land, couple of acres, and somewhere in the order of, I don't know, hundreds of 250,000 cubic yards of concrete in some cases. And that's got a carbon footprint, right? Mm-hmm. And so there's real incentive for these guys to say, okay, if I've got a massive deficit that I've got to take into account. Maybe it's, I think Apple published an 8 million ton deficit. I stand to be corrected on that at 2030. But the cheapest carbon they're ever going to have to deal with is the carbon they don't have to remove from the atmosphere. So if you can buy a low carbon concrete and it costs $20 or $30 more a yard, it's actually cheap. Because if you look what the cost of a removal credit per ton is today, it's not pretty. Mm-hmm. It probably averages out around $450, but I've seen it as high as $1,400. But I think the challenge we got is that there's the technologies are there, but are they there at scale by 2030 to actually give someone 800,000 tons worth of CO2 removal credits? I just, good luck.
Yeah.
That's going to be massive.
Are you putting in the cost data too as well? So if I said, hey, can I have a mixed design that doesn't exceed $170 a yard, and I want it to break at 5,500? You all have something like that?
That's actually part of what we're building right now, where you can actually just do everything from scratch. So at the moment right now, what we do is we typically will use a reference mix that a customer has, and we'll compare it to that reference mix because we know that's been active in the market. And one of the things that you want to be able to do is a client needs to be able to take the product and have a like-for-like substitute, especially on commercial products. The customer still wants to feel like they're getting the same thing and not something new. Yeah, that's definitely coming. That's currently something we're busy with. So, when you move away in our world from kind of the subscription, prescription mix, you can then start going to places where we can provide exactly that kind of service. So you give me the constraints, you want a 6,000 PSI with a 1,300 over design and a 4-inch lump, and you got to pump it through a 4-inch hose, and you want a set time of 4.5 hours, and you don't want it to be more than $170. We'll go ahead and try and figure out what that looks like and give you an option, and see what that looks like. I think, one of the challenges with this is that, every time you want something new and like a new add-on, it's additional development, right? It takes time. It's not like you can just flick a switch and the next thing's available, but it's kind of fun because, everything that we thought was going to be important to folks in terms of getting things like what's going to add value, what's going to create greater savings for the client. It's actually maybe not so much of a priority. I think, I've been really surprised at how a lot of the producers are, especially the quality control folks there. I was always hoping my QC folks were like always there to try and think about the cost optimization and the benefit for the client, but for the client, for us, but also so that the product gives exactly what the client's looking for. But the reality is that, quality control people are really hands-on. So many of them are busy in the field every day, attending to details of clients that this kind of becomes something that goes on the back burner. And, it's part of what we've been trying to do with the business is make this as low-key as possible, as light a touch as possible. So that everything kind of works in the background. And, here's a suggested optimization for you. You can maybe save another $5 or $6 a yard. Do you want to put this into a trial mix and see how it goes?
Mm.
So you want that stuff to be happening in the background so that, folks can keep on doing what they're doing. Cause, I mean, I'm sure you've seen this, but ultimately I've seen a lot of clients, as much as they like talking to the production guys, they believe the QC guy when he comes to the job site and explains, hey, this is what I've seen. This is where we think the strengths are going to go. This is why you can trust it. The ash has got a delayed reaction. It's waiting for the calcium hydroxide to be formed by the hydration of the cement. It's coming. That kind of conversation gets people comfortable. And yeah, I think what we try to do is give people more time to attend to that part of their job and let them not worry about optimization. Let this happen in the back.
So I imagine as they're punching in their mixed designs, your company's just gathering that information in the background, and then the results that they put in, again, you're just gathering that, collecting the data, and then that's what you meant by in the background. And
exactly.
It's a tool for them if they want to call up the information.
And that's why it's a co-pilot. That's why we call it co-pilot. Is that what we also want to do is we want to be able to push information to them as well. So like on a regular cadence, just say, hey, here's a list of opportunities that are potentially available for you right now. Which one's the most interesting? Which is the one that's going to be biggest bang for your buck? Or or ultimately, hey, you've got this project coming up. There are ones that are calling for very specific requirements in terms of low carbon concrete. How can we reimagine it? What is there a price premium? And in terms of that price premium, what's the benefit for the client? So in other words, what you want to also be able to do for them is to say, listen, it's going to cost $1.20 more a yard. Okay, but if you're saving 30% CO2 by paying $1.20 more, this is what that means from an embodied carbon perspective. This is the cost of a removal credit that you're not going to have to purchase in the future. And, this is the net saving. A 30% reduction in CO2 will give you per cubic yard. So there's logic behind this green premium as well. You've got to be able to explain. And I think it's actually interesting. It's definitely tougher in the US than it is in Europe, frankly, because in Europe you already have carbon tax. So by virtue of the fact that you have a carbon tax, there's this kind of pseudo economy. Well, it's not a pseudo economy. You've got the whole cap and trade system that's running there. But you can very tangibly understand what the cost of a ton of carbon is by understanding what you're paying in the form of carbon tax.
Mm-hmm.
And that makes things really clear. And whether we want to, I don't want to see any more tax. Believe me, that's not what I want. But there is a cost to carbon, and there's a cost to carbon avoidance. And people that are buying low carbon concrete fundamentally know that and understand it. It's something additive that they're looking for. They're trying to do an environmental benefit. But the reality is there has to be a cost to that. It doesn't come at a discount.
Yeah. Well, I think, whatever side of the fence you are on the carbon and the carbon taxes and all that, I think the what's really appealing to this technology to me is the building efficiency and making and designing the mixes.
Absolutely.
I've said this numerous times on this podcast, but concrete got its start because it was a efficient, economical building material. That's why it pushed steel to the side, and it was easy to work with. And it seems like lately we're getting away from that. We're trying to figure out reasons to charge people more for the concrete. And what I'm afraid of is, yes, there is a premium there for a better product that we're providing the customer, but we're going to price ourselves out of some of this work that was designed for concrete, and they're going to go, oh, concrete costs this much now I'm going to go look and see if steel works, or maybe God forsaken wood. Uh, I don't want to see any wood buildings.
No,
But
that's no me too. I mean,
yeah,
even I've seen these massive CLT structures that they're starting to put up in Australia. And that's kind of interesting to me. But I had a really interesting experience recently. We were in India, and so we've done we in midway through our first pilot in India at the moment. And absolutely fascinating. Just to give you context, I mean, the one company we're working with there on its own produces around 25% more cement than the entire US.
oh,
One company. Okay. And it's like, okay, now you start looking at scale and you start scratching your head and thinking about this. And, it's again, it's one of the interesting conversations I've had a lot with folks that want to talk about climate and impact of climate is that everyone thinks that, what we do here locally is all that matters. Well, no, because it's kind of like China putting a new 500 megawatt coal-fired power station on the grid every 2 weeks, right? That's a global impact, no matter what you want to think. That's significant. Between India, Indonesia, Malaysia, and sub-Saharan Africa, I mean, the growth rates are just unbelievable. But the one thing every single one of those countries is going to be using for the next decade, and to the extent there's so I don't know, I've got to find this place where I find the number, but basically cement and concrete consumption in the next 20 years is going to be equivalent to what's happened in the whole of the 20th century. So in 20 years, you're going to see literally an entire century's worth of concrete placed. And the reasons are pretty simple. And you said it really well earlier. It's a great product. It's cheap and it's beneficial. And this is really the key part of our mission is that how do we help concrete stay that product? Think about it. I mean, I don't think any product has done more for humanity than concrete. Like people tell, penicillin and no, think about it. How do you have access to water? Dams, concrete dams. Oh, well, look, that's the reality, right? Think about the infrastructure we live in. Okay, people don't like urbanizations. You don't have cities without concrete. You cannot have a steel and glass skyscraper. You couldn't do it at the scale that we have it, right? You don't have access to the infrastructure to manage wastewater and sewage without concrete. It doesn't happen. There is no substitute. And yeah, maybe the ingredients are going to change. I saw a really interesting presentation by Sublime Systems, for example. And they're talking about a megaton production. So basically, effectively, almost I wouldn't say carbon neutral, but like a global warming potential of around 100, 120 kilograms per ton of this product. But even in that scenario, we're talking about 1 million tons in 2029. That's assuming everything ramps up and scales up at the same. The cement and concrete, there may be less of it, but you've got a 5% compound annual growth rate in this industry globally. Again, I'm not don't want to just speak about but if you look at it in its entirety, this thing's going nowhere, man. This is and humans need this product to thrive, and that's the thing I love about it. Like, okay, now what we got to figure out is, how do we do that without pumping 8% of the world's carbon that's going to increase to 12% of the world's carbon in 20 years' time.
Yeah. Well, it sounds like as concrete changes and the composition changes, they'll keep you busy, Alex.
Well, that's the idea. And honestly, that's part of why we like, the platform's so useful is that these other products are going to come online. I think you got to love America, right? If you have a look at even with the DOE funding that came out recently, there's literally tens or hundreds of billions or millions of dollars that went on into new technology. So I know Sublime got some of that money, like companies like Summit Materials, or all these companies are being incentivized by the government to go and start looking and deploying these new technologies. I mean, you think of the way, like there's companies like Brimstone, Forterra, all these interesting guys that are coming online, and that's what we think so exciting is that, we don't care where the material comes from. We're absolutely agnostic. Just let us have at it. If you get enough data, we can start predicting how this is going to do. So, we want to be a complement to those folks. We want to help show them exactly how those, and show producers how that technology can potentially fit in as a substitute for a product somewhere down the line.
Yeah. Yeah. Well, I think this is a good spot to end today, Alex. Thank you for coming on. I will make sure I put Alex's contact information, the website concrete.ai. Check it out. And so, yeah, I'll put the stuff on there so you can get a hold of Alex if you want to work with Alex. Alex, thanks for coming back on the show. It's always good talking with you. And folks, until next time, let's keep it concrete.